Hello, my name is Josh Obert, and I'm a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Farm Ponds tool. This is the second tool in the impoundment siting section of the ACPF toolbox. Drainage areas above farm ponds are smaller than those for nutrient removal wetlands and overlap with drainage areas for water and sediment control basins, or WASCOBs. They range from 5 to 100 acres. Farm ponds, however, will typically be found along drainage ways that are steeper than identified for wetland impoundments or wascobs. There has been recent interest in farm ponds and a diverse use of them, ranging from acting as a fishery production, use for biodiversity, and impacts on sediment detention and movement. There has also been interest in using these impoundments to detain springtime tile drainage water for reuse as irrigation during summertime. This tool may take a while to run, so we will get it started before going over some more details. In ArcGIS Pro, we will open the catalog window on the right side of the screen if it isn't already open by clicking the catalog tab. Expand our ACPF toolbox and expand impoundment siting. Double-click the Farm Ponds tool to open. This tool has 6 inputs that it's asking for. The first is our unfilled DEM. That's our new DEM, and we can add that in the first dropdown as it is already in our map. When choosing the unfilled DEM, 3 of our other inputs auto-populate. These are our flow direction raster, our flow accumulation raster, and our watershed boundary. Optionally, we can include a roads feature class. This is recommended as this will avoid putting in farm ponds across the roadway. We will add the roads feature class from our map. The tool also asks for a z-factor, once again 0.01. Then we have 2 outputs. We get the actual pond feature class and then the pond's drainage area. Click Run to run the tool. The process begins by delineating flow paths from the drainage range established for farm ponds, and that again is the 5 to 100 acres. Those segments contributing 5 to 100 acres are then divided into 100-foot long segments, and these will be used for calculating the slope along each of those segments to look for the proper elevation range. Whichever 100-foot segment has the largest decrease in slope moving upstream along the flow path is selected for further testing. Only one site is tested along each flow path. The midpoint of each selected 100-foot segment represents the point at which the tool will simulate a farm pond installation. To test whether side slopes fall within the 20 to 50% range that meets the NRCS embankment slope standard, buffers of 20, 30, 40, 50, and 60 meters are created out from each tested point. At each buffer distance, the range of elevation values greater than the elevation of the test point is found, and then divided by the associated buffer distance. This ratio is used as a proxy to estimate the side slope of that location. The furthest buffer distance at which this qualification is met is used to determine the impoundment height. This will be set at 80% of the elevation range greater than that sample point. However, if that 80% value exceeds 10 meters, it is reduced to the maximum impoundment height of 10 meters. An impoundment is then simulated in the DEM, creating both the ponding area using the impoundment height found previously and a vegetated freeboard of 1 meter as measured from the top of the farm pond. The drainage area is then delineated and statistics are found. The pond area must be between 0.25 and 8% of the contributing watershed, and the freeboard area cannot exceed the pond area. This allows suggested farm ponds to range between 1/8 and 8 acres. If a site is found to meet this suitability criteria, the site is then kept and used as an output feature class. You'll probably notice that the user cannot change or adjust any of the criteria within this tool. Construction for farm ponds involves significant excavation and earth moving, which changes local site topography drastically. This tool aims to identify locations most conducive to pond construction, where earth moving costs may be reduced, but it does not provide any inventory of all locations where pond construction may be feasible. The only option the user has to help find the most suitable site is to include a roadway feature class, and this will avoid putting ponds where they will flood out a roadway. The Farm Ponds tool has finished running, and we can see that the results, a farm pond feature class and a drainage area feature class, have been added to our map. Let's rearrange these to show the ponds on top of the drainage areas. Click on the ponds in the table of contents, hold and drag above the drainage areas. It is possible that you have a low amount or even zero ponds. This is a tool that relies heavily on the local slope around the midpoint that is selected, so it's a very specific site that it's looking for. Before we change the symbolization on them, let's take a look at the attribute tables. Right-click on the ponds in the table of contents and click Attribute Table. Like the nutrient removal wetlands in the previous tool, there are two features per site ID. There is one for the pond area and one for the freeboard area. They both have the same site ID because they're associated with the same site. The other attributes also repeat themselves. We have the contributing area to the pond area, and then the freeboard area, all in acres. We also have the impoundment height in meters. We finish with values for the pool storage and variable storage, which includes the freeboard area, both in acre feet. If we look at the attribute table for drainage areas, the main item in this table is that each record applies to the site. So the number of records is half of our pond features. Each also has the total area in meters. Now that we understand how our output is built, we can go ahead and symbolize it. We will symbolize the ponds just like we did with the nutrient removal wetlands. Select our ponds in the table of contents on the left and click the Symbology tab in the right panel to open the Symbology window. From the drop-down under Primary Symbology, click Unique Values. We'll be visualizing on the cover type field, so we will select that field from the field drop-down. Click on the color square next to Freeboard. Click on Properties, and then click the color drop-down and click Color Properties. In the hex input, we'll enter A, B, D9, E9. Then click OK. If you do not have Auto Apply turned on, you will need to click Apply. Click the left arrow at the top of the Symbology window. We'll follow the same process with Pond, except using input 313695. Next, click on Drainage Area in the table of contents. In the Symbology window, click the color square next to Symbol. Then click the color drop-down and click Color Properties. We'll enter the hex code FFFFBF, but also change the transparency to 40%. Click OK, and if you need to apply. As a reminder, changing transparency allows us to see what landscape is behind the drainage area. We now have an idea of the actual structure of the pond, what portion is pond and what portion is freeboard. To recap, we ran the Farm Pond tool and discussed how we can use the results to determine the actual structure of our ponds. In the next video, we will run the next impoundment siting tool, WASCOP,